Imagine. It's October 30th, 1961. You're standing on an island in the Arctic Ocean, hundreds of miles from civilization. The sky is gray, the wind is bitter, and somewhere, high above you, a modified Soviet bomber is carrying something that should never have been built. In exactly 90 minutes, the world will witness the most powerful explosion in human history. An explosion so massive that its shockwave will circle the Earth 3 times. So bright that it will be seen from 1,000 kilometers away. So terrifying that even the men who created it will question whether they've gone too far. This is the story of Tsar Bomba, the king of bombs. And it's not just a story about raw power or Cold War paranoia. It's a story about what happens when science pushes past every reasonable boundary, when politics demands the impossible, and when humanity comes face to face with its own capacity for destruction. Because here's the thing that most people don't understand about Tsar Bomba. It wasn't built to win a war. It was built to send a message. And that message was heard loud and clear, even though the bomb itself was never meant to be used. So let's go back to the height of the Cold War, to the secret weapons labs of the Soviet Union, to a time when 2 superpowers were locked in a race to build bigger, deadlier, more unthinkable weapons. Because to understand Tsar Bomba, you first need to understand the madness that created it. The arms race. The 1950s were a strange time to be alive. On the surface, life seemed almost normal. Rock and roll was taking over America. Television was becoming a household staple. The world was rebuilding after the devastation of World War II. But underneath all of that normalcy was something darker, something terrifying. The United States and the Soviet Union were engaged in what historians would later call mutually assured destruction. Both nations were stockpiling nuclear weapons at an unprecedented rate. And with each passing year, those weapons were getting bigger, more sophisticated, more capable of ending civilization as we knew it. It started, of course, with the bombs dropped on Hiroshima and Nagasaki in 1945. Those weapons, devastating as they were, yielded about 15 to 20 kilotons of explosive power. That means they had the destructive force of 15 to 20,000 tons of TNT. Cities were obliterated, hundreds of thousands died. But by the 1950s, 15 kilotons seemed almost quaint. The Americans tested their first hydrogen bomb in 1952. It was called Ivy Mike, and it yielded 10 megatons. That's 10 million tons of TNT equivalent. In just 7 years, nuclear weapons had become 600 times more powerful. The Soviets weren't far behind. In fact, they were often ahead. In 1953, they tested their own hydrogen bomb. Then came a series of escalations, 20 megatons, 30 megatons. Each test was a flex of technological muscle, a way of saying to the other side, "We can destroy you, and don't you forget it." But there was a problem with this logic, if you can even call it logic. Because at a certain point, the destructive power becomes almost theoretical. What's the difference between destroying a city and destroying it 10 times over? What's the point of a bomb so powerful that it can't even be delivered effectively? That's where Soviet Premier Nikita Khrushchev comes in. Khrushchev was a complicated man. He'd risen to power after Stalin's death, and he wanted to prove that the Soviet Union was not just equal to the West, but superior. He believed in the power of spectacle, of grand gestures, of showing the world that Soviet science and Soviet might were unmatched. And in 1961, he had an idea that would make every previous nuclear test look like a firecracker. He wanted to build a 100 megaton bomb, 100 megatons. Let that sink in. That's 100 million tons of TNT. It would be over 6,000 times more powerful than the bomb that destroyed Hiroshima. It would be the ultimate weapon, a weapon to end all weapons. The scientists were ordered to make it happen. The scientists. The man in charge of the project was Andrei Sakharov. If that name sounds familiar, it's because Sakharov would later become one of the world's most famous dissidents, a nuclear physicist turned human rights activist who would win the Nobel Peace Prize for his opposition to nuclear weapons. But in 1961, Sakharov was still working for the Soviet nuclear program. He was young, brilliant, and deeply conflicted about what he was creating. Sakharov had already helped develop the Soviet Union's first hydrogen bomb. He understood the physics, the fusion reactions, the way you could use a fission bomb as a trigger to compress and heat hydrogen isotopes until they fused, releasing enormous amounts of energy. But a 100-megaton bomb, that was something else entirely. The team got to work. They called the project by a simple designation, Product 202. Later it would be called RDS 220, but the name that stuck, the name that captured its sheer absurdity, was Tsar Bomba, the Emperor Bomb, a reference to the massive Tsar cannon and Tsar bell in Moscow, both famous for being too large to actually use. The design they came up with was terrifying in its elegance. It would be a 3-stage thermonuclear device. A fission bomb would trigger a fusion reaction, which would then trigger another, even larger fusion reaction. It was a bomb within a bomb within a bomb. But there was a problem. A 100-megaton explosion would be so powerful that the aircraft carrying it would never be able to escape the blast zone. The plane would be vaporized along with the bomb. It would be a suicide mission. The scientists calculated the numbers, ran the simulations, and they came to a conclusion. They needed to scale it back, not out of mercy, not out of ethical concerns, but out of basic practicality. So they made a modification. Instead of using a uranium-238 tamper in the 3rd stage, which would have undergone fission and added to the yield, they used lead. Lead wouldn't contribute to the explosion. It would actually reduce the total yield by about half. The final design would produce approximately 50 megatons, still the most powerful weapon ever built, still utterly incomprehensibly destructive, but theoretically, possibly, maybe survivable for the delivery aircraft. There was another reason for the change, though nobody liked to talk about it. A 100-megaton bomb would have produced massive amounts of radioactive fallout, so much fallout that it would have contaminated huge swaths of Soviet territory. The scientists later estimated that even the 50-megaton version would produce far more fallout than they wanted. But they had their orders, and by the summer of 1961, Tsar Bomba was ready. The delivery. Here's where things get really interesting. Because once you've built the most powerful bomb in human history, you face a rather obvious question. How exactly do you deliver it? Tsar Bomba was enormous. It weighed 27 metric tons and was 8 meters long. That's over 26 feet. It was so big that it couldn't fit inside any standard Soviet bomber, so they modified a Tu-95 strategic bomber, removing the bomb bay doors and internal fuel tanks just to accommodate the weapon. They painted the entire aircraft with a special white reflective coating, designed to reflect the thermal radiation from the blast. They installed a massive parachute system on the bomb itself, designed to slow its descent and give the aircraft time to escape. The pilot selected for the mission was Major Andrei Durnovtsev. Imagine being in his position. You're about to fly a plane carrying the most powerful weapon ever created into the Arctic, where you'll drop it and then desperately try to fly away before the explosion catches up to you. The survival odds? Maybe 50-50, probably worse. The test site was Novaya Zemlya, a remote archipelago in the Arctic Ocean. It was the Soviet Union's primary nuclear testing ground, far enough from civilization that even a catastrophic accident wouldn't immediately threaten major population centers. Though calling it safe is generous at best. On the morning of October 30th, 1961, the Tu-95 took off. It was accompanied by a second aircraft, carrying observation equipment and cameras. Both planes had been fitted with every protective measure available. Both crews knew the risks. The flight to the test site took hours. Can you imagine that journey? Sitting in a plane with a 50-megaton bomb beneath you, flying over the frozen Arctic, knowing that in a few hours you're going to drop it and pray that physics and engineering will save your life. At 11:30 in the morning, Moscow time, they reached the drop zone. The bomb was released from an altitude of about 10.5 kilometers. That's over 34,000 feet. As it fell, the parachute deployed, slowing the weapon's descent from terminal velocity. This wasn't to protect the bomb. It was to protect the plane. The Tu-95 immediately banked hard and flew away at maximum speed. Bogdanov pushed the engines to their limit. Every second counted. Every kilometer of distance was potentially the difference between life and death. The bomb continued to fall, down through the clouds, down toward the rocky barren island below. At an altitude of 4 kilometers above the ground, the bomb detonated. The explosion. What happened next defies easy description. The fireball alone was 8 kilometers wide. That's 5 miles. For a moment it was brighter than the sun, visible from 1,000 kilometers away. If you'd been standing in Finland, nearly 800 kilometers to the south, you would have seen the flash. The heat was so intense that it would have caused third-degree burns at a distance of 100 kilometers. Anything closer simply ceased to exist in any recognizable form. The island beneath Ground Zero was literally vaporized down to the bedrock. The mushroom cloud rose to a height of 64 kilometers. That's over 200,000 feet. It penetrated through the stratosphere, through the mesosphere, nearly reaching the edge of the thermosphere. The cap of the mushroom cloud was 95 kilometers wide. Think about that for a moment. A cloud of radioactive debris, nearly 100 kilometers across, rising to the very edge of space. The shockwave was detected on seismographs around the world. It circled the Earth 3 times, diminishing each time, but still measurable on the third pass. Windows shattered in villages hundreds of kilometers away. The atmospheric disturbance was powerful enough to affect radio communications across the northern hemisphere for hours. And here's the thing that's almost impossible to comprehend. Tsar Bomba was actually clean, relatively speaking. Remember, the scientists had replaced the uranium tamper with lead, reducing fallout. Even so, the tests still released radioactive particles into the atmosphere that would eventually settle over much of the northern hemisphere. If they'd gone with the full 100 megaton design, the fallout would have been catastrophic. Possibly worse than all previous nuclear tests combined. Back in the aircraft, Bogdanov and his crew were fighting for their lives. The plane dropped nearly a kilometer from the shockwave when it hit, despite being over 200 kilometers away when the bomb detonated. The aircraft shook violently. For a moment, nobody was sure if they'd make it, but they did. The plane survived. The crew survived. And they returned to base, probably understanding better than anyone else on Earth what they'd just unleashed. The aftermath, the international reaction was immediate and split. The Soviet Union announced the test with pride. Khrushchev had gotten his spectacle. The message was clear. The USSR had the ultimate weapon. They had proven their technological superiority. They had shown the world that they could, if they wanted to, destroy anything and everything. But the message was received differently than perhaps Khrushchev expected. The West was horrified, yes, but they were also puzzled. Because what was the point? A 50-megaton bomb was too large to be militarily practical. It was too heavy for ICBMs. It required specially modified aircraft that could barely deliver it. Its massive fallout radius made it almost as dangerous to the user as to the target. It was a symbol, a demonstration, a piece of propaganda wrapped in nuclear fire. And it was also, in a strange way, the beginning of the end of the arms race's most excessive phase. Because after Tsar Bomba, something shifted. The world had seen the absolute limit of destructive power. They'd seen what happened when you pushed nuclear weapons to their theoretical maximum. And it was pointless. Even Andrei Sakharov, the man who helped create it, was deeply shaken. He would later write about his growing moral doubts, about the realization that these weapons served no purpose except to terrify and potentially destroy humanity. He began speaking out against nuclear testing, against the arms race, against the very weapons he'd spent his career building. His transformation from weapons designer to peace advocate would cost him dearly. The Soviet government turned against him. He was persecuted, placed under house arrest, separated from his family. But he never stopped speaking out. The Partial Nuclear Test Ban Treaty was signed in 1963, just 2 years after Tsar Bomba. It banned nuclear weapons tests in the atmosphere, in outer space, and underwater. It wasn't perfect. Underground testing continued. The arms race continued. But the era of massive atmospheric tests was over. Tsar Bomba was never replicated. No country has ever detonated a larger weapon. The bomb tested in 1961 remains the most powerful explosive device ever created and detonated by humanity. The legacy. So what does Tsar Bomba mean for us today? What's its legacy more than 60 years later? On one level, it's a reminder of human capability, of what we can build when we put our minds to it, for better or worse. The engineering that went into Tsar Bomba was remarkable. The physics was elegant. The execution was nearly flawless, but it's also a reminder of human folly, of the madness of the Cold War, of what happens when fear and pride drive scientific progress instead of wisdom and restraint. There's something deeply unsettling about Tsar Bomba. It's not just that it was powerful, it's that it was unnecessary. Nobody needed a 50-megaton bomb. Nobody could even effectively use one. It existed purely to exist, to prove a point, to be the biggest and the loudest and the most terrifying. And yet, in a strange way, maybe it served a purpose after all. Because by being so excessive, so over the top, so clearly beyond any rational military application, it forced people to confront the absurdity of nuclear weapons in general. If you can destroy a city 10 times over instead of just once, does that make you safer? If you can build a bomb powerful enough to see from space, does that make you more secure? At what point does the destructive power become meaningless? These are the questions that Tsar Bomba inadvertently raised. Today, the test site at Novaya Zemlya is still contaminated. The island hasn't fully recovered and probably never will. It stands as a monument to excess, a scar on the earth that will outlive everyone who witnessed the test. The actual bomb casing, or a replica of it, is on display at the Russian Atomic Weapon Museum in Sarov. It's massive, imposing, a physical reminder of humanity's destructive potential. But perhaps the most important legacy is this. Tsar Bomba showed us a limit, not a technological limit necessarily, but a practical and moral one. It showed us that there's a point where more power doesn't mean more security, where bigger isn't better, where the pursuit of ultimate weapons becomes a pursuit of nothing meaningful at all. The story of Tsar Bomba is often told as a tale of Cold War one-upmanship, of Soviet engineering prowess, of spectacular explosions and mushroom clouds. But really it's a story about choices, about what we decide to build, and why, and at what cost. The scientists who created Tsar Bomba were brilliant. They solved enormous technical challenges. They pushed the boundaries of physics and engineering. And in doing so, they created something that should never have been created. Andrei Sakharov understood this eventually. He spent the rest of his life trying to undo what he'd helped build. Not the bombs themselves, but the mindset behind them. The idea that security comes from the ability to destroy, that power means having the biggest weapon. Today, the world still has enough nuclear weapons to destroy civilization many times over. They're smaller than Tsar Bomba, more sophisticated, more accurate. In some ways, that makes them more dangerous, not less. But we've never again built anything like Tsar Bomba. We've never again felt the need to prove our destructive capability quite so spectacularly. Maybe that's progress. Or maybe it's just that we learned the lesson that October day in 1961, when the Arctic sky lit up brighter than the sun, and the Earth itself shook from the force of the blast. Some powers are better left undemonstrated. Some limits are better left untested. And some weapons are best remembered not for what they achieved, but for what they taught us about ourselves. Tsar Bomba was the king of bombs, and like many kings, it ruled over nothing but destruction, leaving behind only questions about what we're willing to do in the name of power and fear. That's the real story of the largest explosion in human history. Not the blast itself, but what it revealed about us.